The next more important thing which people don't realize, but it's a lot of both important from a cost as well as from an efficiency perspective, is the package. So once you have this LED die, you have that typically that package looking something like that with a dome on the top, and then you pack it in a. If you're using a bulb, you have this package on the top which has phosphorus coating, and then you also have this luminaire which is a housing for many of these bulbs together. And a lot of the cost as well as manufacturing costs. So if you see the substrate, the sapphire substrate as such does not add too much cost. The epitaxy of gallium nitride does add around 20% of the cost. Then a lot of the cost actually comes from this packaging. And we talked about packaging with respect to chips, but it's also again very important with respect to LEDs. So this package achieves two dual purpose. It helps in extracting the light. The way it does is that you have a lot of these surface such that you can direct your incoming light out, and also it acts as a heat removal. It plays a very important role of taking that heat out of that system, and taking that heat out of the system is actually very important, because if you have a temperature change in your LED, that can change your output as well as your color of your LED substantially. So this is a blue LED operating at -20°C, but if it rises in temperature by 115 degrees, it completely changes to a red LED. So your color of your LED might change completely if you don't pay attention to this packaging. And both your efficiency decreases if your temperature rises, and your color drifts if your temperature rises. So this packaging and getting that heat out is very important. And LEDs, especially, if you operate them in a cool environment, if you put them in a fridge, they operate much more efficiently if you're able to keep your temperature to a low level. The last thing, which is related to how do we actually operate these LED lamps, or how do we, what control circuitry we use for operating them. And that is actually a very important topic as well, because these LEDs are one of the few devices which uses a diode in a forward bias mode. And controlling a diode, especially in a forward bias mode, is a very difficult thing to do, because your current is exponentially depending on your voltage. So even if your voltage drifts a little bit, if your resistance of your LED changes and you're applying a constant voltage, so if that drifts a little bit, the current can actually change quite a lot. So both the temperature and this voltage is important. So you could have two schemes to drive your LED. You could apply a constant voltage, so you could have a constant voltage scheme, or you can have a constant current scheme. This is very dangerous for LED lamp. So what is more commonly used is you drive it with a constant current source. It does act a little bit of cost, because you have to buy, if you're an E background, you have these buck boost converters. So you have to buy a buck converter which converts a constant voltage source into a constant current source. And there are multiple companies which sell this. National is one of them. But you have to use that if you want to have a stable operation of your LED for your bulb. So another thing which is important with respect to lighting, especially if you're using it in a house, is the ability to dim it. So you could actually have two schemes to dim it. One is you could change the voltage. That's how you typically, most of your dimmers in your house work. And that's the analog dimming. Or you could have this pulse width modulation, where you power your LED with these different pulses, and you change the duty cycle of these pulses to give you different outputs. So the question is, which do you think would be better for dimming the LED? The scheme where you where you just change the voltage or where you use pulse width modulation. So in actual life, what is preferred is PWM based dimming. Though actually analog can also be used and is in fact used many a times. But the again, what you achieve with analog is that your since it's so dependent on voltage, your wavelength can change, your color temperature can change. But with digital dimming, you have that constant current level. And you can, if you switch it on and off very fast, your eye doesn't perceive it, right? Also, these devices don't have any LEDs as such, don't have any reliability problem. You can cycle them as many times. They are much more stable than a flash memory cell, where using that kind of a scheme might get you in trouble. But for LEDs, actually PWM is preferred for LED-based lighting. And especially if you're using that buck converter, that also allows you to achieve this dimming using the pulses. So actually, we probably will stop early today, but let's summarize our learning. So in terms of lifetime, which one do you think has better, right? Or how much is that picture had 1 CFL equal to 10 incandescent. So how much is the lifetime for each? Yeah, so incandescent is about 1000. CFL is around 10,000. And LEDs is, people can say anything, but it doesn't go bad typically. What happens is your output degrades over time. It usually doesn't fuse out or anything. So the people say it's above 30K, that's when your output becomes 70% of the initial output. Dimmable. The LED and incandescents are dimmable, but the schemes used are different. Incandescents typically use analog. They change the voltage, that's how most dimmers in your house work. LEDs use PWM to dim them. Instant on. Yeah, so CFL is not typically instant on. It also has a mercury problem, so you should not throw CFL in your trash and stuff. In terms of cost, I already talked about that. The LEDs are typically 3 to 4 times more expensive than CFL, and incandescents are really cheap. So